Jupiter, the king of planets, the giant that rules our solar system with its immense gravity, swirling storms, and mysterious moons. But what if everything you think you know about this colossal world is only half the truth? For centuries, humans have stared at Jupiter, marveling at its beauty and its power. We've sent spacecraft, captured stunning images, and studied its atmosphere, its storms, and even its magnetic field. And yet, despite all our knowledge, a cloud of mystery still surrounds it. Hidden secrets that some claim NASA isn't telling us. Theories that sound straight out of science fiction claims that Jupiter might be hollow, artificial, or even a failed star masquerading as a planet. Sounds unbelievable, right? But here's the thing. Whether it's the myths or the scientific facts, Jupiter continues to fascinate and puzzle us in ways no other planet does. Its massive presence doesn't just dominate the night sky, it dominates our curiosity. In this video, we're diving deep into Jupiter. We're going to uncover what scientists really know, separate fact from fiction, and reveal the truths that have been hiding in plain sight. By the end, you'll know exactly what Jupiter truly is, not just the gas giant in textbooks, but a cosmic powerhouse that shaped our solar system in ways you probably never imagined. So buckle up, because what you're about to learn might completely change the way you see our solar system and the king of planets itself. When we talk about Jupiter, we're talking about a world so massive, so dominating, that it completely changes how we understand our place in the solar system. Imagine a planet so large that you could fit about 1/300 Earths inside it. That's not an exaggeration or a dramatic comparison. It's a measurement confirmed through decades of observation and spacecraft data. Jupiter is classified as a gas giant, a type of planet made mostly of lightweight elements rather than rock or metal. Its composition is roughly 90% hydrogen and about 10% helium, with traces of methane, ammonia, and water vapor swirling in its upper layers. This means Jupiter has no solid surface like Earth does. If you tried to land on it, you wouldn't find ground, only denser and denser layers of gas, leading into crushing pressures deep within the planet. Jupiter orbits the Sun at a distance of about 484 million miles. One full trip around the Sun takes nearly 12 Earth years, but what's truly astonishing is how fast Jupiter spins. Despite its enormous size, a day on Jupiter is only about 10 hours long. It's the fastest rotation of any planet in our solar system, and that rapid spin is what stretches its clouds into those dramatic bands and fuels some of the most powerful storms we've ever observed. This speed, combined with its size, creates a world that behaves unlike anything we see on Earth. Jupiter's atmosphere churns with winds that reach hundreds of miles per hour. Storms rage for centuries. The Great Red Spot, larger than our entire planet, has been swirling since the 1600s. And deep below the clouds lies a layer of metallic hydrogen, created by pressures so extreme they turn simple gas into something closer to liquid metal. Much of what we know about these inner layers comes from NASA's Juno mission, which continues to send back detailed measurements of Jupiter's gravity and magnetic fields. But Jupiter isn't just another planet orbiting quietly in the dark. It's the ultimate cosmic heavyweight, shaping our solar system in ways we're only beginning to understand. Its gravity has redirected comets, sculpted the asteroid belt, and possibly played a role in protecting Earth from catastrophic impacts throughout its history. Jupiter has been influencing the story of our solar system since long before humans took their first look at the night sky. And now, thanks to modern science and decades of exploration, we're finally starting to uncover just how important this giant truly is. Jupiter's composition and structure. Beneath those swirling clouds lies a mysterious interior that's more alien than anything on Earth. Jupiter's composition is unlike any world we've ever encountered, and understanding what's happening inside this giant planet reveals a story of extreme pressure, exotic materials, and physics pushed to its limits. Jupiter is made primarily of hydrogen and helium, the same ingredients that make up stars like our Sun. In its outer atmosphere, hydrogen dominates at around 90%, with helium making up most of the rest. Traces of methane, ammonia, and water vapor give Jupiter its stunning colors, shaping the chemical reactions that form its famous cloud bands. These clouds aren't just pretty patterns, they're massive, fast-moving systems driven by winds that can exceed 300 miles per hour. Those bands separate regions of rising and falling gases, creating a world of perpetual storms. Among these storms, none is more iconic than the Great Red Spot. This vast, spinning cyclone is big enough to swallow Earth whole, and it has been raging for centuries. The earliest observations date back to the 1600s, meaning the storm has lasted longer than many civilizations. Although it has been slowly shrinking in recent decades, it remains one of the most powerful atmospheric features in the solar system. As we move deeper into Jupiter, the environment becomes far stranger. Under the crushing weight of the upper layers, hydrogen begins to behave in extraordinary ways. At extreme pressures, hydrogen enters a state known as metallic hydrogen. It's still hydrogen, but no longer a gas. It becomes a liquid metal capable of conducting electricity, and scientists believe this metallic layer is responsible for generating Jupiter's enormous magnetic field. The existence of metallic hydrogen on Jupiter was long predicted, but today it is supported by precise measurements from NASA's Juno spacecraft, which tracks gravity variations and magnetic field behavior as it orbits the planet. Between the outer atmosphere and the metallic hydrogen layer, there may be a region of liquid molecular hydrogen, a kind of superheated, superpressurized ocean, with no clear boundary between gas and liquid. Unlike Earth, where phases shift neatly between solid, liquid, and gas, Jupiter's internal transitions are gradual. There is no surface, no landing point, only increasing density and pressure as you fall deeper. At the center of Jupiter lies one of its most intriguing mysteries: the core. For decades, scientists debated whether Jupiter had a solid core at all. Thanks to Juno's detailed gravity mapping, we now know that Jupiter likely contains a dense central region made of rock, metal, and ices. But instead of being a sharply defined solid body, this core may be partially dissolved and mixed with surrounding layers of hydrogen, a structure scientists describe as a fuzzy core. This means that rather than a single compact object, Jupiter's core may be a vast, diffuse region extending far outward from the planet's center. Understanding this internal structure helps us answer one of the most popular questions about Jupiter. Is it a failed star? The idea comes from its composition, mostly hydrogen and helium, the same building blocks of stars. But being made of star material doesn't make Jupiter a star. To ignite nuclear fusion, the process that powers stars, Jupiter would need to be at least 80 times more massive than it is now. Brown dwarfs, the smallest objects capable of limited fusion, still require far more mass than Jupiter possesses. So while Jupiter is star-like in makeup, it lacks the sheer weight needed to trigger the reactions that make stars shine. The truth is even more fascinating than the myth. Jupiter isn't a failed anything, it's a category of its own. A planet so massive that it reshapes its surroundings, yet not massive enough to cross into stardom. A world of metallic oceans and ghostly cores, wrapped in storms that have outlived empires. And the deeper we study it, the clearer it becomes. Jupiter's interior is a realm where the rules of matter bend under pressure, revealing one of the most captivating environments anywhere in the solar system. Magnetic field and radiation. If you tried to stand on Jupiter, you wouldn't survive long. Not just because of the crushing pressure or the lack of a solid surface, but because of the invisible, deadly radiation cocooning the planet. Jupiter has the most powerful magnetic field of any planet in our solar system, a force so immense that it carves out a magnetosphere millions of miles wide. This magnetic bubble is so large that if it were visible in the night sky, it would appear bigger than the full moon, even though Jupiter itself is far beyond Mars. This magnetosphere traps enormous amounts of charged particles, forming radiation belts that dwarf Earth's Van Allen belts. The radiation intensity near Jupiter can be thousands of times stronger than the radiation surrounding our own planet. These belts are filled with high-energy electrons and ions moving at tremendous speeds, creating a hostile environment that can disable spacecraft, damage electronics, and even strip material from nearby moons. The effects of this radiation are not theoretical. Spacecraft sent to explore Jupiter must be heavily shielded, And even then, their systems can suffer from the onslaught of energetic particles. The Galileo spacecraft, which orbited Jupiter in the 1990s and early 2000s, experienced repeated glitches caused by radiation spikes. Later, NASA's Juno spacecraft was designed with a titanium vault weighing nearly 400 pounds to protect its instruments, allowing it to survive repeated passes through Jupiter's harsh environment. Without this vault, Juno would have been crippled within months. Jupiter's radiation doesn't just affect the machines we send there, it also affects its moons. Io, the most volcanic world in the solar system, is bombarded by particles from Jupiter's magnetosphere, creating intense electrical currents that link the moon directly to Jupiter. Europa, one of the most promising locations for extraterrestrial life, is shielded by its icy crust, but the radiation around it is so strong that a human standing on its surface without protection would receive a lethal dose in minutes. These extreme conditions shape the surfaces and atmospheres of Jupiter's moons, carving patterns, adding chemical energy, and influencing the potential habitability of worlds like Europa. One of the most spectacular results of Jupiter's magnetic field is its auroras. These glowing lights at the poles are far more powerful than any aurora on Earth. They are created not only by the solar wind, but also by the constant flow of particles from Io's volcanoes, which get funneled along magnetic field lines and slammed into Jupiter's atmosphere. Juno has provided the most detailed views of these auroras, revealing massive, pulsing rings of light and energy that stand as some of the brightest and most persistent auroral displays in the solar system. Through Juno's ongoing mission, scientists have been able to map Jupiter's magnetic field with extraordinary precision. This data shows that the field is even more complex and dynamic than expected, with regions of intense magnetism, drifting patches, and unusual structures deep within the planet. It is a reminder that Jupiter is not just a world of gas, it is a world shaped by forces powerful enough to influence everything around it, from tiny particles to entire moons. Jupiter's influence on the solar system. Jupiter isn't just a massive planet parked in the outer solar system. Its influence stretches across billions of miles, shaping the architecture of our cosmic neighborhood in ways that most people never realize. In fact, without Jupiter, Earth's history could be very different. Some scientists even argue that without this giant world acting as a gravitational guardian, life on our planet might never have had the chance to take hold. Jupiter's gravity is its most powerful tool. It is more than twice as massive as all the other planets in the solar system combined, and that immense weight pulls on everything around it. One of the most dramatic examples of this is the asteroid belt. Rather than forming a planet, the objects in the asteroid belt remain scattered because Jupiter's constant gravitational tug disrupted the material before it could merge into a larger world. Every orbit, every gap within the belt, and even the location of certain asteroid groups is shaped by Jupiter's invisible influence. Jupiter doesn't stop there. Its gravity also acts like a cosmic bouncer, capturing or ejecting comets and errant objects that wander into the inner solar system. Some comets are pulled into stable orbits around the Sun because of Jupiter. Others are flung out of the solar system entirely, never to return. This ability to redirect or remove potentially dangerous objects has led many astronomers to describe Jupiter as a protective shield for Earth. The famous Shoemaker-Levy 9 comet impact in 1994 is a perfect example. Instead of continuing into the inner solar system, the comet was torn apart and slammed into Jupiter's atmosphere, releasing energy equivalent to millions of nuclear bombs. It was a reminder of just how many objects Jupiter quietly intercepts. Modern simulations from NASA and the European Space Agency reveal an even deeper role for Jupiter. In the early solar system, Jupiter may have migrated inward and then outward again, pulling, pushing, and scattering material as it moved. This migration could have helped shape the orbits of Mars, Earth, and Venus, and may have prevented super-Earth-sized planets from forming closer to the Sun. If such giants had formed near Earth's orbit, they might have destabilized the region entirely. The very stability of our solar system today may be partly thanks to Jupiter's early wanderings. Some studies even suggest that Jupiter delivered water-rich comets and asteroids into the inner solar system billions of years ago, seeding Earth with the ingredients for oceans. At the same time, it helped clear excess debris that could have triggered extinction-level impacts. Jupiter played both roles, the giver and the shield. Whether sculpting belts of rock, steering icy visitors, or shaping the very conditions that allowed life to emerge, Jupiter has been influencing our world long before humans looked up and noticed its bright glow in the night sky. It may sit more than 400 million miles away, but its gravitational fingerprint is written across the entire solar system. Evidence from space missions. Decades of exploration have turned Jupiter from a mysterious dot in the sky into one of the best understood planets in our solar system. But there's still so much more to uncover. Everything we know about Jupiter today, from its magnetic field to its swirling storms to its deep internal structure, comes from a chain of ambitious missions spanning more than 50 years. Each spacecraft added a new layer of understanding, building the foundation for our modern picture of this giant world. The story began in the early 1970s with Pioneer 10 and Pioneer 11, the first spacecraft ever to venture into the outer solar system. Pioneer 10 flew past Jupiter in 1973, capturing humanity's first up-close images of the planet and measuring its intense radiation environment. Pioneer 11 followed soon after, giving scientists a clearer view of Jupiter's massive magnetosphere and the behavior of charged particles surrounding the planet. These missions marked the first time we realized just how hostile Jupiter's radiation belts truly were. A few years later, the Voyager 1 and Voyager 2 spacecraft transformed Jupiter from a blurry orb into a world of swirling color and complex motion. Their 1979 flybys produced detailed photographs of the cloud bands, the Great Red Spot, and even Jupiter's faint ring system, which had never been seen before. They also revealed volcanic activity on the moon Io, the first evidence of active volcanism on another world. The Voyagers gave scientists their first real glimpse of Jupiter as a dynamic, constantly changing system rather than a static world. In 1995, Jupiter received its first long-term visitor. NASA's Galileo spacecraft traveled with the planet for nearly 8 years, orbiting Jupiter dozens of times and studying its atmosphere, moons, and magnetic environment. Galileo even dropped an atmospheric probe into Jupiter's clouds, sending back direct measurements of pressure, temperature, and composition before it was crushed by the overwhelming forces inside the planet. The orbiter revealed Europa's subsurface ocean, mapped Ganymede's magnetic field, and provided the first close-up studies of Jupiter's storms and lightning. As Galileo's mission wound down, other spacecraft briefly passed by Jupiter on their way to more distant destinations. In 2000, the Cassini spacecraft used Jupiter for a gravity assist as it traveled toward Saturn. During its flyby, Cassini captured high-resolution images of the atmosphere and gathered new data about the magnetosphere, helping refine measurements of Jupiter's powerful magnetic field. In 2007, the New Horizons spacecraft also swung past Jupiter while racing to Pluto. Its cameras recorded violent storms, cloud structures, and volcanic plumes erupting from Io. New Horizons studied Jupiter's auroras, measured its charged particle environment, and confirmed rapid atmospheric changes happening in real time. But the most transformative mission of all began in 2016, when NASA's Juno spacecraft entered orbit around Jupiter. Unlike previous flybys, Juno was designed to map Jupiter's interior, magnetic field, and deep atmospheric layers with unprecedented accuracy. It discovered that Jupiter's magnetic field is far more irregular and complex than scientists expected. It measured the depth of the jet streams that create the planet's iconic cloud bands. And Juno's gravity readings revealed Jupiter's fuzzy core, a sprawling region of mixed elements rather than a compact solid center. The spacecraft also captured incredible images of polar cyclones, auroras, and massive storm systems that give us a new perspective on Jupiter's weather. Each mission built upon the last, turning Jupiter from a distant mystery into a detailed world with layers of complexity. And even now, with Juno still sending home data, Jupiter continues to surprise us, proof that even the best explored giants can still hide secrets. Myths and fringe claims. Despite the wild theories you see online, real science leaves little room for these dramatic claims, but they do make for fun stories. Whenever a planet is as massive, mysterious, and visually stunning as Jupiter, myths rise quickly. And over the years, Jupiter has attracted some of the strangest ones. From claims that it's hollow, to ideas that NASA is hiding life there, to theories that the images we see are fake, the internet never runs short on speculation. But the truth, backed by decades of observations and measurements, is far more fascinating than any conspiracy. One of the most persistent myths is the idea that Jupiter is hollow or even an artificial structure. The reasoning usually sounds dramatic. A giant planet with swirling clouds and no solid surface must be hiding something inside. But gravity tells a different story. Jupiter's mass, measured precisely through spacecraft flybys and orbital mechanics, matches exactly what you would expect from a dense, massive object made of gas and deeper layers. Juno's measurements of Jupiter's gravity field confirm that the planet's interior contains a huge amount of material distributed throughout, including a diffuse core. A hollow object simply wouldn't produce the gravitational pull Jupiter exerts. Another common claim suggests NASA is hiding life inside Jupiter's clouds. It's an idea inspired by science fiction, but the real conditions of Jupiter's atmosphere make this extremely unlikely. Temperatures in the deeper layers soar to thousands of degrees. Pressure increases to levels far beyond what any known organism could withstand. And radiation near the planet is intense enough to destroy organic molecules in minutes. Even Europa, one of Jupiter's moons, is considered a far more realistic candidate for life than Jupiter itself. Then there's the myth that Jupiter is actually a brown dwarf, a failed star secretly glowing with its own fusion. While it's true that Jupiter is made of the same material as the Sun, it simply doesn't have enough mass to ignite nuclear fusion. To become a star, Jupiter would need to be around 80 times more massive. Brown dwarfs, the smallest objects capable of limited fusion, are vastly denser and heavier than Jupiter. This comparison has been thoroughly documented in both NASA and ESA studies. Perhaps the most modern myth is the claim that NASA is faking images of Jupiter. But long before digital image processing existed, Pioneer, Voyager, and ground-based telescopes were capturing consistent patterns in Jupiter's atmosphere. Every mission that has ever visited the planet from Galileo to Cassini to New Horizons has produced images that match the same atmospheric structures, storms, and cloud bands. These independent observations span 5 decades and multiple space agencies, making the idea of a coordinated illusion impossible. While these myths may be entertaining, the reality revealed by science is far more impressive. Jupiter doesn't need conspiracy theories to be fascinating. It's already one of the most extraordinary worlds in the solar system, no exaggeration required.
Fun facts and mind-blowing insights. Jupiter is full of surprises, and every fact is more incredible than the last. Even after decades of missions and research, this giant continues to reveal details that almost sound unbelievable. One of the most striking is its rotation. Despite being the largest planet in the solar system, Jupiter spins faster than any other. A single day on Jupiter lasts just about 10 hours. Its rapid rotation stretches its clouds into long, colorful bands and shapes the powerful jet streams that tear across the planet. Then there's the Great Red Spot, one of the most iconic features in our entire solar system. This massive storm is larger than Earth and has been raging for more than 3 centuries. Observations dating back to the 1600s show a persistent oval shape, though its size and color have changed over time. Today, spacecraft like Juno continue tracking its winds and temperature variations, giving scientists clues about how such a storm can survive for hundreds of years. Of course, Jupiter's sheer size remains one of its most mind-blowing traits. It is so enormous that you could fit about 1,300 Earths inside it. Its mass alone is more than twice that of all the other planets combined, giving it unmatched gravitational influence across the solar system. Jupiter also puts on a light show that dwarfs anything on Earth. Its auroras are gigantic, forming glowing rings at the poles that can be larger than our entire planet. These auroras are powered by Jupiter's intense magnetic field and by interactions with the volcanic material streaming from its moon Io. Observations from the Hubble Space Telescope and Juno have shown just how energetic and dynamic these auroras can be. And perhaps one of the most dramatic moments in Jupiter's history was the impact of Comet Shoemaker-Levy 9 in 1994. As the fragments slammed into the planet, they left dark scars larger than Earth's diameter, visible for months. The event proved that Jupiter acts like a cosmic shield, capturing or destroying objects that might otherwise threaten the inner planets. Even with all we know, Jupiter remains a world of extremes, mysteries, and wonders, a place where every new discovery feels bigger than the last. Jupiter is not just a planet, it's a cosmic powerhouse. A gas giant made mostly of hydrogen and helium, swirling with storms bigger than worlds, spinning faster than anything else in the solar system. It carries a magnetosphere so enormous and intense that it could swallow the sun, and radiation belts strong enough to destroy unprotected spacecraft in hours. Beneath its clouds lies a deep, complex interior of metallic hydrogen and a mysterious core that Juno is still helping us understand. And all around it orbits a vast family of moons, from volcanic Io to ocean-bearing Europa, from massive Ganymede to ancient frozen Callisto, each one a world with its own secrets. Jupiter's gravity shaped the asteroid belt, redirected comets, and may have even protected Earth from catastrophic impacts throughout history. It has been called a failed star, a planetary guardian, a miniature solar system, and a cosmic giant that influences everything around it. Even after centuries of observation and decades of space missions, it continues to surprise us, challenge us, and remind us how little we truly know. And that's the beauty of exploring worlds like Jupiter. The more we discover, the more mysterious it becomes. If you enjoyed diving into the secrets of our solar system's most powerful planet and want more jaw-dropping cosmic stories, make sure to like this video, subscribe to the channel, and hit the bell icon so you never miss the next adventure. The universe is full of wonders, and we're just getting started.